GFCI protection is addressed according to the National Electrical Code. The NEC requires GFCI protection for all 120 volts outlets located in damp or wet locations such as bathrooms, kitchens, and outdoors. If a rooftop air conditioning unit is not located in a damp or wet location, GFCI protection is not explicitly required for the 120 volt service outlet by the NEC. However, regarding 208 volts control wiring, the NEC mandates that all wiring be installed with a ground wire. If the 208 volts control wiring was run through a drop ceiling in non-metallic flexible conduit without a ground, this is not compliant with the NEC. There are exceptions to the grounding requirement in certain circumstances, such as when the wiring is installed in a metal raceway or conduit. However, if the wiring is not installed in a metal raceway or conduit, the control wiring should have been installed with a ground wire. Recommendations include, firstly, installing a GFCI outlet for the 120 volts service outlet even though it is not strictly required by code, as it provides additional protection against electrical shocks. Secondly, replace the 208 volts control wiring with wire that includes a ground wire to ensure proper grounding and compliance with the NEC. To elaborate further on the requirements for ground fault circuit interrupter protection, the 2023 NEC Article 210.8 provides detailed information on where GFCI protection is required. Some specific examples, in addition to bathrooms, kitchens, and outdoors, include unfinished basements, garages, and accessory buildings at or below grade level. The general rule is that 120 volts through 240 volts receptacles installed in locations considered to be readily accessible in damp or wet should have GFCI protection. Readily accessible is defined as capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. With regards to grounding and bonding, the NEC provides specific requirements in Article 250. This article covers the general requirements for grounding and bonding electrical systems to ensure a low impedance fault current path. Section 250.4 describes general requirements for grounding and bonding, emphasizing that electrical systems must be grounded in a manner that limits the voltage imposed by lightning, line surges, or an intentional contact with higher voltage lines, and that stabilizes the voltage to earth during normal operation. Section 250.118 identifies acceptable grounding conductors, which include copper, aluminum, and copper-clad aluminum conductors. These conductors can be solid or stranded, insulated, covered, or bare, and must be protected against physical damage. With regards to wiring methods, Chapter 3 of the NEC provides details on approved wiring methods for various applications. Article 300 covers general requirements for wiring methods and materials, emphasizing the need for wiring to be securely fastened and protected from physical damage. Article 334 specifically addresses non-metallic sheet cable and NEC cable, outlining the requirements for its use in dry locations. If an NEC cable is used, it must be supported and secured according to NEC requirements, typically every 4½ feet and within 12 inches of boxes or fittings. Regarding the specific scenario of running wiring through a drop ceiling, the NEC generally permits this, provided that the wiring is adequately supported and secured. However, the space above a suspended ceiling may be considered an environmental airspace plenum if it is used for environmental air for heating, ventilation, or air conditioning systems. In such cases, wiring must be plenum rated, as specified in Article 300.22c. Plenum rated cables, such as CMP cables, are designed to limit the spread of fire and smoke. With respect to the equipment grounding conductor, the NEC specifies its importance in providing a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protection devices such as circuit breakers or fuses. Section 250.4 FIV emphasizes that the earth shall not be used as the sole equipment grounding conductor. The equipment grounding conductor must be run with the circuit conductors within the same raceway or cable. Article 250.134 outlines the requirements for equipment grounding conductor connections. Metallic and non-metallic equipment. Grounding conductors must be connected to the grounding bus within the panel board or service equipment. Bonding, as covered in NEC Article 250.92, ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed. Bonding involves connecting all non-current carrying metal parts of an electrical system together, creating a low impedance path for fault current. The NEC also addresses the protection of conductors and equipment. Article 240 covers overcurrent protection, specifying the requirements for circuit breakers and fuses to protect conductors and equipment from overloads and short circuits. The ampacity of conductors must be selected based on the load they will carry, and the overcurrent protection device must be sized accordingly. NEC Table 310.16 provides ampacity ratings for various conductor sizes and insulation types under different conditions. For example, a 12 American wire gauge copper conductor with THHN insulation has an ampacity of 20 amps at an ambient temperature of 30 degrees Celsius, assuming not more than 3 current carrying conductors are in a raceway or cable. If the ambient temperature is higher, or if there are more than 3 current carrying conductors, the ampacity must be derated according to NEC tables. In summary, adherence to the NEC is crucial for ensuring electrical safety and compliance. GFCI protection is essential in damp or wet locations, and proper grounding and bonding practices are necessary to provide a safe path for fault current. Wiring methods must comply with NEC requirements, including the use of plenum-rated cables in environmental airspaces and the proper support and securement of wiring. Overcurrent protection devices must be properly sized to protect conductors and equipment from overloads and short circuits. It is always recommended to consult with a qualified electrician to ensure compliance with the latest NEC requirements and to address specific electrical needs and conditions. When dealing with electrical installations, it is essential to consider voltage drop. Voltage drop refers to the decrease in voltage along a conductor due to the impedance of the conductor and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Section 210.19a provides guidance on voltage drop, recommending that the voltage drop on branch circuit should not exceed 3% at the farthest outlet for power, heating, and lighting loads, or 5% for feeders plus branch circuits. To minimize voltage drop, conductors should be sized appropriately based on the length of the run and the anticipated load. Online voltage drop calculators and NEC tables can assist in determining the appropriate conductor size. Regarding working clearances and access, the NEC requires adequate working space around electrical equipment to allow for safe operation and maintenance. NEC Section 110.26 specifies minimum working clearances based on voltage levels in the presence of exposed live parts. For example, for equipment operating at 150 volts to ground or less, the minimum working clearance is typically 3 feet. For equipment operating at higher voltages, such as 600 volts, the minimum working clearance may be 3.5 feet or 4 feet, depending on the conditions. Clear access pathways to electrical equipment must be maintained, and the working space must be kept clear of obstructions. Proper labeling and identification of electrical equipment and circuit are also essential for safety and maintenance. NEC Section 110.22 requires that overcurrent protection devices be clearly marked to indicate the purpose or equipment served. Panel boards and other electrical enclosures should be labeled with the circuit directory, indicating the loads served by each circuit. Wire identification is crucial for tracing circuits and preventing accidental misconnections. Conductors should be identified using color tape, labels, or other approved methods. The NEC also addresses safety-related work practices. Article 110.8 requires that electrical work be performed in a neat and workmanlike manner. This includes ensuring that connections are tight, conductors are properly supported and secured, and equipment is installed according to manufacturer's instructions. Qualified persons should perform electrical work, meaning individuals with the skills and knowledge related to the construction and operation of electrical equipment and installations and have received safety training to recognize and avoid the hazards involved. Lockout-tagout procedures must be followed when working on de-energized equipment to prevent accidental energization. Personal protective equipment such as gloves, safety glasses, and arc flash suits should be used when working on or near energized equipment. Regular inspections and maintenance of electrical systems are essential for identifying and correcting potential hazards. Visual inspections should be conducted to check for damaged or deteriorated wiring, loose connections, and overloaded circuits. Insulation resistance testing can be performed to assess the condition of insulation and detect potential ground faults. Thermographic surveys can be used to identify hotspots in electrical equipment, which may indicate loose connections, overloaded circuits, or failing components. Any identified issues should be promptly addressed by a qualified electrician to prevent electrical failures or safety hazards. In summary, compliance with the NEC involves adherence to a wide range of requirements related to GFCI protection, grounding and bonding, wiring methods, overcurrent protection, voltage drop, working clearances, labeling and identification, safety-related work practices, and regular inspections and maintenance. It is essential to stay informed about the latest NEC requirements and to consult with qualified professionals to ensure electrical safety and compliance.